Hi everybody, welcome to another video in Calculus 1, section 3.2, working with derivatives. So this is going to be a very short section, so that's we'll look at derivative in terms of graphically and all of the little details before we actually learn how to find derivative. I would actually go through some rules of finding derivatives. Right, so in this case, just by graph. So what we know up to this point is the derivative is the slope of the tangent line, right? The previous section, the slope of the tangent line is, let's just review, slope of the tangent line at the point is f of x plus, a plus h minus f of a over h. So this is the tangent line, slope of the tangent line. At x equal to a. Now if instead of a we just have x instead of a, so what we have is the derivative. So pretty much the same thing, depends on what values we substitute in. So we can say derivative is the slope of the tangent line. Right, now take a look at that. So first, based on the graph here, what can we say? So first, from -5 to -2, the slope here is equal to what? It's going down. So the slope, way back in grade school, we learned that the slope, loosely speaking, it just rise over run. Slope of the line. So let's say we go from this point, rise, so we're not going up, so we go down. So we go down 1 and 1 to the right. So rise, if we go down, is negative. So -1 go down and 1 to the right. So rise over run. Since we're going down, it is negative. So on this part, the slope is equal to -2. So we say, the slope is equal to -1. For this part, slope is equal to -1. So in this example, we will sketch the graph of the derivative, meaning we sketch the graph of the slope. Since the slope, we can say the derivative equal to -1. So from -5 to 2, the slope is equal to -1. From -5 to -2. And it is undefined at -2, so we don't just put an empty circle at those points. So from -5 to -2, the slope is equal to -1. Next, the slope from -2 to 0, rise over run, 1 up, 1 to the right. So the slope for this portion is equal to 1, and the slope is the derivative. So we have from -2 to 0, the slope is 1. And next, for this, for that portion, slope is rise over run, so we go down 1 and 2 units to the right. So -1/2. -1 go down, 2 units to the right. And the slope is also the derivative. So from 0 to 5, it is -1/2. I should make the scale a lot bigger than this. again, it will be undefined at those points. So that's what we have. So this is the graph instead of y. This is the graph of the derivative. Right. So simple enough, right? Just write the slope and that. Right. Next. Also, if the graph of the function is like this, we sketch the graph of the derivative. Right. So what's special about this graph? Remember, we have one example like this on the previous section, where we say if slope of the tangent line is equal to 0, we have the horizontal tangent line, and in that case, if the slope is equal to 0, meaning that the derivative equal to 0. So we have a few points here. At those points, at this point, which is -3 and 1, the slope equal to 0, right? And also at -1. The tangent line for those points, the slope is equal to 0. So slope equal to 0 for these 3 points. -3, b. Slope is equal to 0 is -3, at 0 at -1, and at 0 equal to 0 at 1. So at those 3 points. Right, next, what do we have? Let's look from -4 to -3. Look at that part. First of all, if we're talking about the slope, it would be the tangent line. If we talk about the tangent line, it will be like this. It will go up, therefore it is positive. The slope is positive for that part. Right, but not any positive number though. Originally it is extremely steep, and then less and less the tangent line gets smaller and smaller, and essentially equal to 0. So from -4 we can say the slope start out very big number but gets smaller and smaller and essentially go to 0 at -3. Next, for this part, the tangent line is going down, so it is negative, right? The tangent line is pointing down, is going down. If the line going down, the slope is negative, therefore the derivative is negative. So it is negative, but not just any negative number. It starts from 0 and it just gets more and more negative. But then after that it will be less and less negative and go back to 0. So we start with 0, more and more negative, and then back to 0. And then next, this part is going up, so the tangent line also going up. If the tangent line going up, the slope is positive. Slope positive, the derivative is positive, but not just any positive number. It starts out from 0 and get bigger and bigger, but after that it will get smaller and smaller and go back to 0. So we have this. And finally, for this portion, the function going down. If the function going down, the tangent also going down. If the line going down, the slope is negative. The slope is negative, derivative is negative. And this start now from 0 and get more and more negative. So it will be like this. So that is the graph of the derivative function based on the graph of the function. Right. So simple enough, right? Right. Next we have a theorem. If f is differentiable at the point A, then it is continuous at A. The contrapositive of that is, if it is not continuous at A, then f is not differentiable at A. Bottom line, this is just a small part of the bigger theorem. The bigger theorem says the function is differentiable, meaning it has the derivative at the point A if at least one of the following condition holds. Actually, the key word here is not differentiable, meaning that derivative does not exist at the point. So first of all, if there's a gap, there cannot be the slope of the tangent line at that point, right? If the function is not continuous, then it cannot be the slope because there's no point there. If it has the corner point like this, the reason if it has the corner point and it doesn't have derivative, because the way we define it to be limit, we want the limit from the left and limit from the right have to equal to the same number. In that case, the derivative exists. If we have one function on the left, the slope is equal to something, and the slope on the right is something else. That's like when we have a corner, then the derivative does not exist. So this is the case where we don't have derivative. And also have the vertical tangent, simply because vertical line, the slope is undefined. Vertical line has undefined slope. So if the slope is undefined, the derivative is the slope of the tangent line. So if it's undefined, the derivative is undefined as well. So we cannot have those three things. The function not continuous, there will be no derivative. The function has the corner point. The limit on both sides do not agree. There's no limit, there's no derivative. I mean, the limit I'm talking about is the definition of the derivative. And finally, the vertical tangent line, it will not work because tangent line, if it is vertical, the slope is undefined. And if the slope is undefined, the derivative is undefined as well. So we have these three scenarios. It cannot have anything that is not continuous. Cannot have a corner or a sharp turn, and cannot have the vertical tangent. Right. Next we have this example. We have the graph here. First, based on that graph, I'll find the values of x in the interval -4 to 4, where the function is not continuous. So where it is not continuous, it's easy, right? Where there is a gap. So it's -2, and there's a gap at 2. So the function is not continuous at 2 and -2. So at x equal to 2, -2, and at x equal to 2, the function are not continuous. Right. Furthermore, at -2, there is the gap. Discontinuity. Or I think the better word for that is a jump. And at 2, it is removable. Discontinuity. This is, let's say, jump from one point to the next. Right. Find the values at x in the interval at which the function is not differentiable. Right. First of all, if it's not continuous, there will be no derivative, or it's not differentiable. So x equal to -2, and at x equal to 2, it is not continuous. If it is not continuous, it will be not differentiable. It have to be continuous to find the derivative. differentiable. And what else? So at x equal to 0, notice that if we talk about the tangent line, on the left side it approaching to a tangent line like this, and on the right side approaching to a tangent line like this. So, and also if we just keep going like this, the pattern, it has a vertical tangent at 0, so we cannot have the vertical tangent. So at x equal to 0, we have vertical tangent, or we have a corner point. Either way, we cannot have derivative. So because of vertical tangent, it has a vertical tangent, or because there's a corner, depends on where we see it. The graph is not very clear, or because of the corner point, or any sharp turn. There's no derivative, so it is not differentiable. And now let's sketch the graph. So any special here, we know, really we don't know much about this. None of that equal to 0, so that to base off. It's kind of difficult. We know from -4 to 2 though. The slope here is positive, and then it's positive, and look like the slope is increasing as well. So from -4 to -2, the slope is positive, and original a little flat, and then pick up. So maybe from -4 to -2, we have like that. The slope, it is positive, and start from small number and increasing. Maybe not that much, but that's just the idea. And then from -2 to 0, the slope starting from 0, and then get negative, essentially become vertical. So if I want to draw this portion of the graph, I start out from 0 at -2, and then get more negative, essentially become vertical. So have that. And then this part of the graph, it starts from the vertical tangent, and then get closer and closer. Eventually it closed almost to the horizontal line, but it's not there. So we just say it from here. We start from a very big number and get smaller, eventually go to 0. Right, and after that we have this portion here. So we start out from 0 and get smaller, more negative. Start from 0 and get more and more negative. Right. So once again, it is positive, and it gets increasing. The slope gets steeper and steeper. And then next, start from 0 and get more and more negative. 0, more and more negative. Next, start from almost a vertical line, and then was less and less, more at equal to 0. But again, it's not and it's not defined at that point. And then we start from 0 and change from negative, more negative. If the tangent line going down, the slope is negative. The steeper the line, the higher the derivative. So if it is like this, the derivative is very big number. And then if it's the vertical tangent line, it's either infinity or negative infinity. But in either case, it's not differentiable. Right, so that's all I want to cover in this section. Just the relation of the graph of the function and the graph of the derivative. Bottom line is, derivative is the slope of the tangent line. If we want the derivative, we cannot have any of this. The function has to be continuous. It cannot have any corner or any sharp turn. it cannot have the vertical tangent line. When one of them fails, the function doesn't have the derivative. Right, so pretty much that. Starting next section, we will learn how to find the derivatives by learn different rules of finding derivative. But for now, just the basic of derivative. And it's just later on, if anybody asks you what is the derivative, the answer will be it is the slope of the tangent line. That is the physical interpretation of the derivative, and in the definition as well. Right, so with that, I finished this section. As always, thank you for watching, and see you in another video in Calculus 1.